Myself, Dr. Prashant Kumar Boltu, Professor, Department of Mechanical Engineering, GIS College of Engineering, Kolkata. My subject of is Advanced Welding Technology, NE 703A, lecture number 11, Diffusion Welding, DFW. Diffusion welding is a solid-state welding process which produces coalitions of the fairing surfaces in the application of pressure and elevated temperature. This process does not involve microscopic deformation, melting, or relative motion of the parts. Filler metal may or may not be used. This may be in the form of electroplated surfaces. The process is used for joining refractory metals at temperature that do not affect their metallurgical properties. Heating is usually accomplished by induction, resistance, or furnace. Atmosphere and vacuum furnaces are used, and for most refractory metal, a protective inert gas atmosphere is desirable. Diffusion welding. Successful welds have been made on refractory metals at temperatures slightly over half the normal melting temperature of the metal. To accomplish this type of joining, extremely close tolerance joint preparation is required, and a vacuum or inert atmosphere is used. The process is used quite extensively for joining dissimilar metals. The process is considered diffusion bridging when a layer of filler material is placed between the fairing surfaces of the parts being joined. These processes are used primarily by the aircraft and aerospace industries. Definition, schematic figure, working principles, applications, titanium diffusion welding, nickel diffusion welding, advantages, limitations. Definition of diffusion welding: a solid-state welding process that produces coalitions of the fairing surfaces by the application of pressure at elevated temperature. The process does not involve macroscopic deformation or relative motion of the workpiece. The solid filler metal may or may not be inserted between the fairing surfaces. Schematic figure. This is workpiece A and workpiece B. This is force is applied, and the schematic representation of diffusion welding using electrical resistance for heating. Electrical circuit is electrical resistance is given so that diffusion takes place between the two metal parts through the heat. Diffusion welding working principle. Stage 1, first stage. Asperities come into contact. This is come into contact. First stage is deformation and interfacial boundary formations. This is interfacial boundary formations. Stage 2, grain boundary migrations and pore eliminations. Grain boundary migration and pore eliminations. This is the third. Second stage, grain boundary migration and pore elimination. And this is the third stage, volume diffusion, pore elimination. Volume elimination, pore elimination. This is the third stage. Diffusion bonding, a process in which the strength of the joint results from diffusion primarily and plastic deformation of the fairing surfaces. Diffusion is the movement of atoms across the interfaces. Temperatures about zero point 0.5 melting temperature absolute. Bonded interface has the same physical and mechanical properties as the base metal. Strength of bond depends on pressure, temperature, time, duration, temperature, time of contact or duration, cleanliness of fraying surfaces. Bonding may be facilitated by use of a filler metal at the interface. For some materials, brittle intermediately compound may form an interface, prevented by electroplating the surfaces. Diffusion bonding use high pressure autoclaves for complex parts, suitable for joining dissimilar metals, most common reactive metals, that is titanium, beryllium, metal matrix composite materials, an important parliamentary sintering mechanism, relative slow process to allow time for diffusion. Automation enables economic production in moderate volumes. Aerospace, nuclear electronics require skill operator. Diffusion welding. Diffusion welding is dependent on temperature, time, and applied pressure. Temperature and time are related to characteristics diffusion states described in the above equation. Pressure influences diffusion only in a more complex way. Compressive stress must be present in diffusion welding, but the required loading might be well below the room temperature yield state of the material being welded. Factors influencing diffusion welding, relation between temperature and diffusion coefficient. D is the diffusion coefficient, and the relation between the D is equal to coefficient is equal to T0. T0 diffusion constant, e to the power minus Q. Q is the activated energy by KT. K is a Boltzmann's constant and T is absolute temperature. T is absolute temperature. So T0 e to the power minus K by Q by KT. This is the diffusion coefficient. This is the factor influencing the diffusion value. Factors influencing diffusion welding, the temperature affects diffusion coefficient, time, x is equal to diffusion length, C is a constant, D into T, diffusion coefficient into T is the time to the power half, 1 by 2 is equal to diffusion length. Factors influencing diffusion welding. Diffusion welding is accompanied by a certain deformation of parts. This deformation depends mainly on bonding temperature, bonding time, and bearing pressure. Unfortunately, influences of temperature and bearing pressure are non-linear, making it difficult to predict the deformation of a new design. This is the original interface position. This is the contact point. Concentration of B. This is B parts and this is A parts. Concentration of component of A and 0% B parts to 100%, and this is 0% component of A to 100%. This is the original interface position. Interface position. So how the bonding takes place. This is another figure. This is Metal B and metal A. This is the where some inserted. This is pure metal B and pure metal A. This is where interface of weld. This is A figure and this is E figure. The penetration curve, how the penetration curve is or possibly A, original interface. This is original interface and this is X. Interface changes 0 to 100% A. Another figure will show you how the interfaces changes. PB is greater than TA. This P, this is A, interface markers. This is initial conditions, and this is marker. This is mark, and the changes. And this is the third marker migration. This is a figure of three positions. Interfaces changes. This is the position with maximum interface changes. This is minimum, and this is porosity. This is porosity, changing some porosity occurs. This is aerospace diffusion bonding applications in where the bond, diffusion bonding takes place. This is this position. Different positions, diffusion welding takes place. So different positions takes place. This is sequence of operation in the application of a structure by the diffusion bonding and superplastic forming of three original flat sheets. After this different and welding B and C, this is the figure A, B, C. This is bonding takes place. And this is bonding. This is figure again takes place. This is C figure. Division bonding takes place. How this is division bonding takes place. Application of diffusion welding. Application in titanium welding for aerospace vehicle. Diffusion welding of nickel alloy include Inconel 600, Rod, Udiment 700, and Rene 41. Dissimilar metal diffusion welding application include copper to titanium, copper to steel, aluminum, copper to columbium, 1% zirconium. Brittle intermetallic compound formation must be controlled in these applications. Titanium diffusion welding temperature as high as possible without damage to base metal, 75 to 100 degree Fahrenheit below alpha beta chances, that is 1700 Fahrenheit, is around 850 degrees centigrade. Time varies with other facts below, but 1 hour to 4 hours typically required. Pressure near yield at temperature. Smooth playing surfaces, rough surfaces, usually more time on pressure. Clean surface is usually acid cleaning. Space shuttle design to have 28 diffusion welding components. This is the titanium base alloy and size. titanium alloy. This is the figure. This is superplastic foam and diffusion bonded titanium heat exchanger. This is heat exchanger. Titanium alloy. This is a welding is done. This range welding is done. This portion. Another welding is done. This portion. This is welding is done. Nickel diffusion welding, more difficult to weld, temperature close to melting point, high pressure because high hot strength, clean surface, ambient atmosphere control, surface oxides do not dissolve. Nickel filler often used especially for rough surface. Typical diffusion welding conditions for some nickel-based alloy. This is a Inconel 600. Pillar material is nickel. This is 1090 degree centigrade, 100 to 500 psi, and 0.5 hours. Wrist alloy. This is nickel alloy, 1120, 100 to 500 psi. This is 4 hours is required. Pressure. Rod rudiment 700, nickel 36% cobalt, 1120, 1000 psi. This is 4 hours. Cast element 700, nickel 35% cobalt. This is 1190, 1200 pressure psi. That is 4 hours. This is alloy 41, nickel base alloy 1180, is 1550 and 2 hours. So another alloy 200 M200, nickel 25% cobalt. This is 1205 degree centigrade, 1000 to 2000 psi, and 2 hours required. Pressure, temperature, time is 2 hours required. So typical diffusion welding condition for some nickel-based alloy. Diffusion welding of dissimilar metals. An intermetallic phase or a brittle intermetallic compound may form at the weld interface. Selection of a appropriate filler metal can usually prevent such problems. Joint designs can help also. Low melting phases may form. Sometimes this effect is beneficial. Porosity may form due to unequal rates of metals transfers by diffusion in the region adjacent to weld. Rekindle porosity, proper welding conditions, or the use of an appropriate filler metal, or both may prevent this problem. Some specific application of diffusion welding. Recent application of diffusion joining of Japanese industries. This F-15 fighter plane, they uses titanium-based alloy. So so different materials are uses in Japanese recent application of the diffusion material. recent application of diffusion joining for the Japanese industries. So mostly alloy material, alloy material, and nickel-based alloy material. Other nickel-based alloy. Disadvantages: this solid-state process avoids pitfalls of fusion welding. Dissimilar materials weld are possible. Properties and microstructure remain similar to those of base metals. Multiple welds can be made in one setup at the same time, produces a product finish to size and causes minimal deformation, presents less sinkage and stresses compared to other welding processes. Highly automated process does not need skillful workforce. Limitations: costly equipment, especially for large weldments, costly preparation with smooth surface finish and exceptional cleanliness, protective atmosphere or vacuum required, long time to completion, it is 4 hours, mostly 4 hours, minimum 2 hours is required, not suited to high production rates, difference in thermal expansion of members may need special attention, limited non-destructive inspection method available, applicability of diffusion welding. Diffusion bonding is primarily used to create intricate for the electronics, aerospace, nuclear industries. This is often done using titanium or aluminum alloy for parts needed in the aerospace industry. Typical materials that are welded include titanium, beryllium, and zirconium. In many military aircraft, diffusion bonding will help to allow for the conservation of expensive strategic material and the reduction of manufacturing costs. Some aircraft have over 100 diffusion bonded parts, including fuselages, outboard and inboard actuator fittings, landing gears, titanium and nacelle frames. Application of diffusion welding, application in titanium welding for aerospace vehicles. Diffusion welding of nickel alloy includes Incoron 600, Rod Ultimate 700, and Rene 41. Space shuttle designed to have 28 diffusion welding components. Similar metal diffusion welding applications include copper to titanium, copper to aluminum, and copper to chromium 1% zirconium. Brittle intermediately compound formation must be controlled in these applications. Questions. Number one, diffusion into the metal component to be joined in is required on solid state welding, glass mark welding, electron beam welding, laser welding. Answer is solid state welding. Number two, welding process in which electrical arc resistance to flow of electricity or combustion of gases is not required to produce heat. Cold welding, solid state welding, diffusion welding, and thermite welding. There is also diffusion welding. Question and answer. Which one of the following gives correct relationship between temperature, diffusion coefficient for diffusion bonding process? 2 points are there where T is your diffusion coefficient, T0 is diffusion constant, Q is activation energy, T is absolute temperature, K is Boltzmann's constant. Now here the D is equal to D0 e to the power K by KT, Q by KT, D is equal to D0 e to the power Q by KT, D is equal to D0 e to the power KT by Q, and D is equal to D0 e minus KT by Q. So no answer is not correct. Score is 0. Correct answer is T is equal to D0 e to the power minus Q by KT. This is the question association completed. So thank you very much. Thank you.